So anytime that we are reflecting means that we're taking something and we're flipping it over to the other side. So if something is on the left side of the line of reflection, it should wind up on the right side. If it's on the right side, it should wind up on the left. Now that's if your line of reflection is going to be vertical like this one, but there are times where a line of reflection could be diagonal, could be horizontal. So we just have to keep a lookout there and make sure that we are following all of our rules for reflections. Now you may not know how to do reflections yet, so what I'd like to start with is actually tracing all of the things that are on this page. I'm going to trace point A, I'm going to trace point C, point B, and connect those dots to make my triangle. I'm also going to be tracing the line of reflection, which is labeled with L. And the tracing doesn't have to be perfect, as long as you got something kind of close to it. And so finally, I'm going to trace, I'm trying to keep that lined up there. Finally, I'm going to trace this figure, whatever you would want to call it. And so when I'm going to show a reflection, I want to flip the paper over, because that's what a reflection is. It takes something and it flips it to the other side. So I'm going to flip it, but how should I actually be flipping this paper? Like, where do you think it should line up, or what should line up? So hopefully you're looking at this and you're saying, ooh, this line of reflection right here should line up on both sides. Now, if we look at this, this is our reflected images. So we see that figure D wound up over here now. We see that A, B, and C wound up on the other side of the line. Or, well, kind of on the other side of the line. Which point, if you're looking at everything here, didn't really wind up on the other side, but somewhere else? Hopefully you're seeing that figure B, this point right here, is directly on the line of reflection. Now, one thing that you do want to be sure of when you're reflecting is that any time that you have a point, we could measure that distance. And let's say that it's just 2 centimeters. I don't know what it actually is. I'm just going to make up a number there. If that was 2 centimeters, then the distance of your reflected point to the line of reflection should also be 2 centimeters. The distance should be the same for your original point, whatever that was, so A in this case, to the line of reflection, as your new point to the line of reflection. So say C to the line of reflection is 8 centimeters. If that's the case, then what should be the distance from C prime to the line of reflection? Based on what we set up here, we should see that if this is 8, then this is also 8. Now there's something else that's really important that we should also notice. When you make a straight line that connects those points, they should intersect your line of reflection at a 90-degree angle, or a right angle. That's always going to be true with a reflected point, with a reflected image. If you connect the original to the new one, it should make a 90-degree angle. So with that being said, I'm going to go down here. Now, I don't have a ruler on me right now, but what I can do is I can draw a relatively straight line. And if I see this line keeps going, keeps going, keeps going, keeps going, oops, and I just lost my place there. But if it keeps going, then we're going to see that it matches up with this point over on the other side. Every single point, whatever you pick, has a corresponding point on the other side. Take a guess as to what you think the word corresponding means. Essentially, the word corresponding just means that if you have a point on one side, it should match up with a point on the other side. So this point right here would match up with this point right here. Our original image should have a reflected image there. One thing that I haven't done is I haven't put my correct labels yet. This label should be A prime now because it's our new image. This one should be C prime. And this one, even though it's on the same exact point, should be B prime. Figure D should be D prime. Prime, that little symbol right up top, just means that we've transformed it one time. If we did reflect this and then maybe translate along a vector so that it was now down this way, I'm just going to sketch it really quick. Yeah, and I'm not an artist, but if we were to do that, then we could call that D prime prime. There'd be two of them to show that we've done two transformations, both a reflection, which got us over here, and a translation. So just a couple things that you should be thinking about when we're doing reflections there. Now, the next example is looking at something a little bit different. And instead of reflecting everything this time, what we're going to be doing is I just want you to take a look at it. If we were going to reflect this angle, ABC, across the line of symmetry, or the line of reflection, obviously it's going to be over on this side, so somewhere over here. But what would the measure of the reflected angle be? So now let me sketch it real quick. If I were going to reflect this, what would the measure of this angle be when we reflected it? Now, what you should notice is that every angle, every line segment, every shape should be the same exact size. So if this was 66 degrees here, this should also be 66 degrees here. If this was 5 units long on the right side, then when we reflect it over to the left side, it should also be 5 units long. When we reflect, the size and shape does not change. The only thing that changes is where the new shape is. And that new shape should always be on the other side of the line of reflection. So I'm actually going to fast forward a little bit more. There's a couple more questions that I wanted to talk about today, starting with the other side of this page. And this is a key one right here. We haven't talked yet about two things. One is a horizontal line of reflection, so going from left to right. And the other is, what if the line of reflection is going through the shape? Can we still reflect it? We absolutely can. So we still follow the same process that we did before. And you know what? Instead of using the transparency paper, I'm going to go without. I'm going to eyeball this, and then I'll trace it afterwards to see if I traced it or if I did my measurements correctly. Every single point, based on what we were saying, should be the exact same distance away from the line of reflection. So if I just kind of eyeball this, then E prime should be right about there. This second rule that we have to remember is when we connect those, it should intersect that line of reflection at a 90-degree angle. So if we follow that same rule for F and G as well, then I can keep this line going down. Those look to be about the same size. I'll put my F prime right here. G, because it's below the line of reflection, I'm actually going to have to reflect it up. So we are still going over the line of reflection. It's just that all the points that are on top go to the bottom, while the points on the bottom go to the top. So I've got that distance there, whatever it is. I'm going to eyeball it to see. Probably right about there. Now I could be using a ruler for this, and if you guys have a ruler at home, I would strongly encourage you to do that. But when I connect these 3 points, I get this triangle right here. So you might be wondering, well, is that correct or is that not? Well, how we can test it is if we trace the original triangle. So we've got E, F, and G. I'm going to keep the labels as well to make sure that all of my points are labeled correctly. I'll trace the triangle. And then what else should I trace? After I trace this triangle, I should also trace the line of reflection, because when I do that, I know where it's going to line up when I flip it over. So now I can take my transparency paper and flip it. And I'd say that the reflection that I made, E prime, F prime, G prime, it is pretty darn close. I might be off by a little tiny bit, but not bad for not having to measure. So that's a trick that you can always use. If you don't have transparency paper, but you want to make a reflection, the two things that you have to remember are that the distance from the point of from the line of reflection to each point should be the same, and they should make a 90-degree angle when that connecting line intersects the line of reflection. So the last thing that I wanted to talk about today is labeling points. Just like we were talking about earlier with our A prime, B prime, C prime, E prime, F prime, G prime, all of the things that we've talked about today, we can also label unknown values and unknown measurements based on what we have here. So I'm going to zoom in on this a little bit more. This is the very next page in lesson 4. And this time, first of all, looking at these, we know that figure A is our original because it says this is our reflection. What's another way that we can tell that figure A is our original and this is our reflection? We should notice that the F and the H don't have the prime next to it. So if the F and the H don't have the prime next to it, those have to be our reflected images. Now, if we look and we connect those two dots right there, they will make a 90-degree angle when they intersect. That means that this has to be our F prime, while this has to be our H prime. We can also label this 4 units because we know that the distance between the two is 4 units. Looking at our triangles here, what should we label this point right here based on the triangle that we have over here? Since this is I, this one must be I prime. They are the same distance away from the point of reflection, and if you were to connect those dots, they would make a perpendicular bisector to the line of reflection. If this is K, where should K prime be? It's that other unknown value of this triangle on the other side. So if this is J prime, this must be J. Is there anything else that we can label on either one of these triangles? So this one has some angles that are missing. This one says that it's 28 degrees, which means this must be 28 degrees. 2, 8. 31 is further away from the line of reflection, so 31 must be the further away angle over here. And then finally, I prime J prime is 7 units. That means that IJ, the reflected side, should also be 7 units. Last but not least, we're going to do this third image. We know that B is our angle based on what it says here, which means that B prime must be our angle here. What's the measure of this angle here? Well, if B prime is 150 degrees, then B must also be 150 degrees because they don't change shape, they don't change size. The only thing that changes is their location. What should be the label for this point up here? We can see that it should be A prime because A is further away from the line of reflection. So A prime should be the point that's also further away. That makes this last one C prime here. So we've now labeled every single one of these missing values, missing points, all based on the little bit that we've talked about reflections here. What I'd like you guys to do is check out Khan Academy. Make sure that you understand how reflections work. And if you are having trouble, make sure that you send me an email. Make sure that you are reaching out to me one way or another, and I'll be happy to answer any questions that you guys have.